Okay, dear students, let us see this question. Balmer gave an equation for wavelength of visible region of hydrogen spectrum as lambda is equals to k into n square by n square minus 4. Then the value of k in terms of Rydberg constant is how much? So they are asking, this is the question. You observe, whenever they gave like this, first of all, you should go with the hydrogen spectrum's formula. 1 by lambda is equals to R into Balmer series N1 value is 2. So it is 2 square minus N is there in this. So N is nothing but N2 only. So we will write that is N square. Hydrogen Z value is 1. So Z square is 1. Now you have to find the lambda from this one. After that, you compare that one with this only. Okay. So first of all, what is this answer? We will see. What is its LCM and all these things. This is R into 1 by 4 minus 1 by n square. Its LCM is 4n square. So we will write this one as n square minus 4 divided by 4n square. Here before this we have R is definitely will be there. So therefore what is this lambda answer from this one is lambda is equals to R into n square minus 4 divided by 4n square. So it will become reverse only. So then what I will do is this I will make it reverse, means the 4n square will come in the numerator and R into n square minus 4 will come in the denominator. So this is what we got the lambda answer. But given answer is what? K into n square by n square minus 4. N square minus 4. If you cancel these things, then 4 by R, whatever is there, that will become equals to K. That means K is equals to 4 by R. So we have given the K value in terms of Rydberg constant. So 4 by R is the answer for K. So this is the right option. Okay. Okay, dear students, let us see this question. The frequency of radiation emitted when the transition of electron takes place from n plus 1th level to nth level. N plus 1th level to nth level. So n plus 1th level is excited state, nth level is lower state will be. But here one more condition given, n extremely greater than 1. We will make use of this condition if necessary in the simplification. Let us see what is the exact formula we are using for this hydrogen spectrum. That is 1 by lambda is equals to R into 1 by n1 square. n1 square is lower level is n square minus higher level is n plus 1. So n plus 1 whole square. And not talking about hydrogen, so we can call it as Z square is the formula as per the Rydberg equation. And in this, you want to find the frequency, then frequency is nu by lambda, nu is equal to C by lambda. So that C also we will introduce here. That C is velocity of the light. So radiation, C into R into 1 by n square minus 1 by n1 square 1 by n plus 1 square into Z square. So here, if you try simplifying this one, it will become C into R. This is n plus 1 whole square, n plus 1 whole square minus n square divided by n square into n plus 1 whole square into Z square. Now open up this n plus 1 whole square, then it will become CR into Z square into this will become n square plus 2n plus 1 minus n square divided by n square into n plus 1 whole square. Here n square got cancelled. The rest part of that value in the numerator is 2n plus 1. So then we will write this one as CR into Z square into 2n plus 1 divided by n into n plus 1 whole square. So now if you just consider this is n square into n plus 1 whole square, consider n is extremely greater than 1. The given n is extremely greater than 1, it indicates that n plus 1 we will consider as approximately equals to n. N plus 1 will consider equals to n only. So in such case, what will be this n plus 1 value? We will check it off. Okay, and one more, 2n plus 1 is there. 2n plus 1 also will become equals to 2n only in this condition. When n is extremely greater than 1, 2n plus 1 will become 2n and n plus 1 will become n. Therefore, what is frequency? What is frequency is 2n plus 1 is 2n divided by n square is n square only. N plus 1 square is also n square. So n plus 1 will become n square into n square is n power 4. Before this we have CR Z square is there. So I'll write this is 2 CR Z square. N by n square, n power 4 is n cube. So this is n cube. So frequency is 2 CR Z square by n cube. 2 CR Z square by n cube. Here we should consider this condition as if they have already given, then n is extremely greater than 1. Then if you consider that, you will get the 2 CR Z square by n cube. The same type of problem if they give here n minus 1, you can apply, you will get the same thing. That means frequency is inversely proportional to n cube. Okay, this is the right answer for this question. Thank you very much. Okay, let us see the next question. If nu1 is the frequency of series limit of Lyman series, nu2 is the frequency of first line of Lyman series, and nu3 is the frequency of series limit of Balmer series, then identify any one of the correct relation in these options. So first of all, we should know that frequency formula, Rydberg equation, Balmer series, okay, or Lyman series equation. So what is the Rydberg equation known to us is nu is equals to C into 1 by lambda, that is equals to C into R into 1 by lambda is nu bar. So that value given in the Lyman series is 1 square, n1 is 1 square, limit means n2 is infinite. So then this expression will become frequency of series limit of Lyman series, then it will be, yes, CR, this will be CR, this will become CR only, let it be. Next, nu2 we will find. What is nu2? Nu2 is equals to C into 1 by lambda is equals to C into R 1 by Lyman series first line means n1 is 1, n2 is 2. So it is 1 square minus 2 square. 1 minus 1 by 4. 1 minus 1 by 4 is 3 by 4. So it is 3 into C into R by 4. That is nu2 answer. What about nu3? We will see what is nu3. Nu3 is the frequency series limits of Balmer series. So for Balmer series, what is the equation is C into R into 1 by Balmer series n1 value is 2. So it is 2 square minus limit, series limit they are telling means n2 is infinite to infinity. 1 by infinity square is 0. So it is 1 by 4. 1 by 4 means CR by 4. It is CR by 4. So it is 1. This is 1. This is 3 by 4. This is 1 by 4. You observe this one. Value 1 minus 3 by 4 means 1 minus 3 by 4 is 1 by 4. It means if you subtract this nu 2 from nu 1, you will going to get nu 3. That's all. So nu 1 minus nu 2 is equals to nu 3. This is the right answer for this question. So I am considering CR as 1, CR by 4, 3 CR by 4 is 3 by 4 and CR by 4 is 1 by 4. So this is nothing but 1 minus 3 by 4 is 1 by 4. So 1 is the first one, nu 1, 3 by 4 is nu 2, 1 by 4 is nu 3. So this is the right option for this question. Thank you very much. Hi dear students, welcome to my session on JEE-NEET objective questions. In this session, a few questions, different questions I will discuss. See the first question. An excited hydrogen atom returns to the ground state. As we all know, excited atom returns to the ground state. In that, there will be an emission of energy in the form of photons. Definitely is possible. They are telling the wavelength of emitted photon is lambda they have given. Definitely the emission of energy takes place and that photons wavelength given as lambda, as we all indicating the wavelength with lambda. Now the question is, the principal quantum number of the excited state will be, principal quantum number symbol is small n, that value you have to calculate using the hydrogen atom only. Okay. In this particular juncture, I would like to give you that hydrogen spectrum related formula. Ground state means that is n is equals to 1. You can consider n1 is equals to 1. Excited state means you can consider n2 is n only as a symbol for principal quantum number. In these two cases, if the electron is coming from the n2 state to n1 state means n2, the n, small n, principal quantum number higher level 2, the ground state is 1, then in such case, what is the lambda answer? As far as the considerations are taken when n is equals to 1, Lyman series concept is going to come, in which the formula for the hydrogen wave number, spectrum wave number, spectral line, the excited state, nu bar is equals to 1 by lambda is equals to r into 1 by n1 square I am taking as 1 square, 1 by n2 square I am taking as n square. Okay. This is for hydrogen, so z value is 1, so 1 square is 1, z square is 1, so I am not taking that 1, okay, directly as it is coming. So you have to find the n value and see the any one of the options of n value. First of all, you can do the simplification of this 1 by 1 square is 1 minus 1 by n square. So this you can write it as r into 1 is r minus r into 1 by n square is r by n square will come. So in this, we have to find the n answer. So what we do is 1 by lambda is equal to r minus r by n square. That will write it as r by n square is equals to r by n square is equals to r minus 1 by lambda. This 1 by lambda I will send that side. Then what will happen, we will check it, that is equals to lambda into r minus 1 divided by lambda. Now you send this r towards right side, it will undergo cross multiplication, then it will become 1 by n square is equals to lambda r minus 1 divided by lambda r will come. Now we have to find the n square answer. What is n square answer from this expression is lambda r by lambda r minus 1 will come. Okay. So if you just consider this is the value, you are going to observe the same type of thing, but n is the answer you have to find. This is n square. You send that to that side, then it will divide. That means 2 will become 1 by 2 that side. So then what is n? So square root of this is lambda r by lambda r minus 1 whole power 1 by 2. This is what the principal quantum number of the excited state, what they have asked in this question. So n value is lambda r by lambda r minus 1 whole power 1 by 2. So this is the right answer for this question. Okay.